Oh. Okay, so what I have is I have the amount of time it took people to complete the survey. I can create a whole whack load of people. Let's just do 100. Let's do 120. 120. There we go. I didn't do it right. God's sakes. So I'm just making up some data. So I have 120 people. And this is, I'm doing a random number. So this is the amount of time it took them to complete the survey. Control. I'm gonna, random is something it's screwy. It does, this is not a procedural length control, it's dynamic. So now that I've got it, I'm just going to paste it as text. Okay, so there we go. So now I have, this is the amount of time it took them to complete the survey. And I have 120 people. Okay, now if I can do like a frequency distribution in this, it's not going to work out very well because this is time, and this is in time in, let's say time in seconds. Now let's just wrap it. Sorry, I talked to myself too much. Okay, so now if I did a frequency table, a frequency distribution of this, I'm going to have pretty well a unique value for every value because it's carried to 2 decimal places, right? So if I can do this in Excel really easily, you don't have to know this. So I do a survey completion time, and then I do a count. Don't do sum. Why does it default to sum? It's so stupid. Count. So I have one person at 124.03 seconds, another person at 127.49. I have no duplicate records. Okay. And I've got 100 and I have 100, basically 120 records. And they range from 124 up to 356. Okay, so my range, so the range is 124.03 up to 356.86. Okay. So I have a range of a little over 200. Okay, 200. Hundreds will give me. So now what I have to do is I got to kind of like now create a group frequency distribution. And I got to figure, okay, how the hell am I going to do this? So I've got 124 and I want to create about 10 rows of data. So I'm looking at my range is equal to 356 minus, so I got about a 232. So in terms of groupings, if I want to, this number of groupings I have. So if I have 2 groupings, my interval width of my groupings roughly would have to be roughly 120, 115 or so seconds. All right, so that's okay. That's 2 groupings, but I don't want, I can do 3, 4, 5, 6, 7, 8, 9, 10. No, let's make 11. Let's go up to 12. Okay, and that's equal to this. Divide by 3. So that's units of 77 milliseconds. Okay. So if I'm somewhere between 9 and 10 groupings, and that's what I kind of like want. I want about roughly that many groupings. I'm going to roughly have an interval, and I want something that fits in a nice numeric way. So I'm looking at increments of 25 seconds. Increments of 25 seconds will give me a nice breakdown, right, in terms of frequency distribution. So if I look at my sheet here, now the first thing I'm going to do is I'm going to want to sort it, right? Remember I did before with the memory task, I wanted to sort. So in Excel, I'll do a custom sort here, and I'll sort by completion time, smallest to largest. There, that's the participant number. Okay, so for my group frequency distribution, what if I should get fancy? Let's go, I want to go in units of 25. So let's go, to make it really clean, I'll go from 100 to, I'm 2 decimal places, 1.00 to 124.99. Now, and here's my F, right? So this is my grouping. So here's my first grouping, and let's do it in a gray. And that's this one person here. My next grouping is 125.00 up to 149.99. And that's going to be this group right here. And I'll make them this ugly orange. And that's equal to, so this is equal to count. This is equal to, I'm just using funky Excel functions. One, two, three, four, 5, 6, 7, 8, 9, 10, 11, 12. It works. And then I want 150.00 to 174.99. And that's going to be this group right here, which I'll make this pukey color. And that's equal to, I'm going to count them up in Excel. Tedious, 175.00 to 199.99. So I've got my 4 units, and that's going to be 99. There we go. And I'll make that, oh, this lovely kind of like that blue. Equal to count. This is a quick way of an Excel of doing a frequency count. Should be 13. And then I want 200.00 to 224.99. And I'm going to make that this colors under the rainbow, green. And that's from 200 to 224. That's that. See how this is, you can see how this is tedious. Oh, maybe I'm losing people like flies. It's like, oh no. And then 125.00 to, oops, 225. 0.00 to 249.99. Now you can see how it's starting to rotate around. I'm doing it in quarters, and I'm going to make this, color code this. Let's make it that color. And that takes us to 249.99. And that's equal to count. Okay. And I will post this, so, and then 250.00 to 274.99. And I've got to color this one. I haven't done any reds. Let's go with this. Okay. 50 to 274, getting near the bottom here. Okay. Equal to count. I'll go through this, get it done. Then my next one is 275.00 to 299.99. And I got to pick a funky color. We're getting near the end. Let's go with a, oh yeah, I like that. All right, bear with me. And then 300, 0 to 324.99. Let's pick a color. Oh, next green. Okay. Getting near the end. And then 325.00 to 349.99. Let's make that run into colors. I'll make it really dark. Oh, I got one more after this. Okay. Okay, then the final one is 350.00 to 374.99. And let's leave it white. Equal to count. There we go. Maybe I should take it a color there. Okay. Let's make it dark gray. So see how I've created a group frequency distribution with really what's referred to as numeric data, right? Where it's to do decimal places. Okay. Now the key thing here is, and this is where we talk about real and apparent limits. Okay, so I'm going to yeah. So I'm just going to tidy it up. Just going to copy it out. Control copy. Okay, so that's how it would look in its clean form. I'll center it. Okay. Now, this is where we get into what's referred to as apparent and real limits. Okay, let's just do this. Okay. So apparent lower limit. Okay. Right, and this is basically what we see. Oh. And then equal to, oh, I can do right. Okay. Now, parent limit interval width. If I look at my interval width using this, my interval width looks to be from here minus here, which is 24.99. Okay. Now, that's not correct because the interval width I'm using is actually 25. I'm going up in increments of 25. But if I use the apparent limits, what it looks like my interval width is 24.99. Well, it's technically not true because I can't look at 100.00 as kind of like 0. I actually am including that value. So it makes it kind of screwy when I think of it in the context of apparent limits. Now, what I need to do is I need to look at it from the perspective of real limits. Let's put that over here. Now, in the lecture notes for this, we're almost done. Thinking of real and apparent limits is roughly the same idea as yeah, I have to think of it kind of like the border between, say, for example, two properties. So here's a picture of my property. The red line is the neighbor's property. Now the border is actually an imaginary line that separates the two properties. And the reason that it's an imaginary line that doesn't really exist is because the border itself, it gets skinnier and skinnier till infinity, right? So it kind of like it approaches in 0 but never hits it. What do I mean by that? Well, let's say the neighbor wants to build a fence along this red line here to separate our two properties. He says he wants to build a fancy, very expensive stone fence that's going to be 2 feet wide. And I say, there's no effing way you're doing that. Because if you build a 4-foot wide, beautiful stone fence, 2 feet of that fence is going to be on my property. You're going to put it right on the middle of the property. So if he puts that fence on the property line, that means that there's going to be 2 feet on my side and 2 feet on his side. And I go, no. If that fence is going to be on the property line, it is not going to be 4 feet on 2 feet on my side and 2 feet on your side. It's got to be skinnier. They go, okay, well, I'll build a fence with with 2x4s. So it's 4 inches wide. And there's going to be 2 inches on your side and 2 inches on my side. And I go, that ain't happening. I don't want any of your fence. If the fence is going to be on the property line, which it has to be, then I don't want 2 inches of that fence on my property line. If the rule is it has to be on the property line, it can get infinitely small. It could be the width of a pebble of sand. I could still bitch and complain. So the real border between two properties is actually an imaginary number. You technically can't physically go out and with the highest degree of accuracy mark out that border, because in terms of accuracy, it just gets infinitely thinner and thinner and thinner, and asymptotes to zero. It just approaches zero, but doesn't get there. That's how you have to think about real and apparent limits with frequency distributions. So, for example, the length of the coast of England. If my unit is 200 kilometers and I map that out, the length of the coast of England is 2,400 kilometers. If my ruler is 100 kilometers long, the length of the coast of England is 2,800 kilometers. If my unit of my ruler is 50 kilometers, I'm using a 50-kilometer ruler, the length of the English coast goes to 3,400. The length of the English coast gets infinitely large. I could measure it down to the individual grain of sand and keep going around and around every grain of sand and measuring the coast of England. I could go down to subatomic particles and measure it. My unit of measure and my fineness of my ruler, as it gets infinitely smaller, the coast of England gets infinitely larger. So it really is, you can't really say with 100% accuracy what the length of the coast of England is. You can approximately say, okay, if I use this measure to this level of accuracy, this is what it is. It's the same thing. It's a weird artificial concept with limits. So now the apparent limit, so if I have, let's say I have an interval of 125.00 and 149.99, right? So there's my, that's my width. And then I have the next one down is, let's say, 100.00 to 124.99. Okay, so there's my my apparent limits. So okay, what there is there's an imaginary border between those values, right? It's analogous to the border between my property and the neighbor's property. So the border, which is the real limit, which I really think of as the border, it's halfway between, for the next level down of accuracy, because as I get more and more accurate, more and more decimal places, okay, cancel. Oh, I don't want to do that. It gets, okay, border, real limit. It's the next level down. It's the halfway point between my apparent limit, which would be 124.99. And if I had a value of 124.99 seconds, I would include it in that first grouping. The border between the two, between 124.99 and the upper limit of that first interval, and 125.00, which is the lower limit of the next interval, apparent limit, is equal to 124.995. That is the real limit. Now I can go one more up. So the next interval is going to be the 150.00 to 174.99. The real limit here is halfway, but the border between the two, which is the real limit, is 149.995. That's the, and it's, I don't actually have a value of 100 and let's say 149.995 seconds. I could have 149.99 and it would go in this grouping right here. But this is, the real limit is an imaginary border between my two groupings. Okay, so now this will be my real limit. And my upper limit now, see how my interval width has changed? When I use a border, an artificial border between my intervals, and I calculate my interval, my real limit interval width, I can see how my interval width actually is 25. So you see how that works? So I have to think in terms of real limits when I'm creating my groupings, because I want my groupings to be something that is coherent in terms of a 10-base decimal system. Going up in units of 25 works, but the units of 25 is based on really our using real limits and kind of like thinking in my head that way. And then if now I can add this as a chart. Oh, let's see, there we go. It's kind of like random stuff. Design, select data. There. And I can make that a bit bigger. Okay. It's a okay. Does anybody have any questions on that? I see questions, sorry. I got a new version of yeah, if it's you're saying from 1 to 7, so let's say let's say 1 to 7, and then yeah, so that's my real limits. So the apparent lower limit, sorry, I'll just I'll get rid of this too. Well, I can just do it here. That's I'm sorry. I'm just going to add it in as another sheet. Sorry. So the parent lower limit is 1, the parent upper limit is 7, and then real limit. The real lower limit is going to be 0.5. And the The real upper limit will be 7.5. And then the I know I'm kind of, I shouldn't, is equal to this minus this, which is, as you said, 7. Yep. So someone asked, what's the interval width for a range from 1 to 7? I would base it on the real limits. Yes, and the apparent limit would be 6. That's right. Yeah, but in your head, you always got to, that's why it's always really important to think that way, because sometimes you get balled up when you're creating your intervals. You can see how I'm going up in units of 25, 100, 125, 150, 175, 200, 225, 250, 275. I'm going up by units of 25. I can get tripped up if I'm thinking of the apparent limit interval width, which is 24.99. No, that's not true. I need the full range of values. And the full range of values between 124.99 and let's say between 125 and 149, the border for those range of values goes from the lower real limit, which is the lower border of 124.995, which I don't have a value for. It's an imaginary border, up to the upper real limit of 149.995. Yeah. Let's call these limits. So that's in a nutshell is limits. I'll upload this. What's sheet 3? I don't need that. It's just in sheet 1. So that's group frequencies. I'm just going to move this chart back. I don't need that. That's okay. There. Okay, my table, it's going to be messy. We're trying to print it. So let's just file save. Okay. I'll stop the recording. That's technically the end of the class, and I'll post this.